Ever wish you could stretch the day and add an extra hour? Well, in the distant future, we might get our wish. Scientists have discovered that Earth's day is gradually lengthening, and we could one day experience a 25-hour day. But here's the catch. This change comes with a dark side. The same forces extending our days will eventually freeze Earth's rotation, leading to endless days and nights, massive storms, and shifting oceans. Time might not be the gift we hope for. Let us go way back in time to understand how all of this started. Back when the Earth was just a massive, messy cloud of dust and gas, gravity started pulling everything toward the center. As all that loose debris and space dirt smashed together into a giant ball, the whole thing started to swirl around. Think about what happens when you fill a bathtub with water and then pull the plug. The water does not just drop straight down. It swirls and spins in a circle as it rushes down the drain. The dust and gas that made the Earth did the exact same thing, but on a huge cosmic scale. That spinning motion created a very strong moving push. Because space is a vacuum devoid of air resistance, our planet just kept rotating, establishing the roughly 24-hour cycle we measure today. But here is the interesting thing about that timeline. We all adopted 24 hours as the length of a day, but that is really just a very close guess. It is an estimate. In real truth, a day is never exactly 24 hours long. Basically, the Earth keeps spinning in space, but it is constantly losing tiny little bits of its speed. Why is it losing speed? That happens mostly because the heavy stuff on our planet keeps moving around. To understand this, I want you to think about a figure skater on an ice rink. Picture a skater spinning around and around in circles on the ice. If the skater pulls their arms in very tight against their body, what happens? They instantly speed up and spin much faster. But if they stretch their arms far out to their sides, what happens then? They slow down. The Earth does the exact same thing as the skater, except the Earth does not have arms. It has rock and water. When things shift on the Earth, the spin changes. For example, back in the year 2011, a terrible earthquake hit the country of Japan. This earthquake was so incredibly strong that it shifted the heavy floor of the ocean in a very violent way. That huge movement pulled a lot of the Earth's heavy mass inward, closer to the center of the planet. Just like the ice skater pulling their arms in, this made the Earth speed up just a tiny bit. It instantly shortened our day by 1.8 microseconds. A microsecond is a piece of time so small you cannot even feel it, but it still happened. On the other hand, the opposite thing happens too. Right now, huge mountains of solid ice, which we call glaciers, are melting. As this heavy ice melts into water, that water rushes away from the poles and moves toward the middle of the planet, which we call the equator. When this heavy water spreads out, it is just like the ice skaters stretching their arms far out to the sides. The Earth's arms are spreading out, and this is causing us to drag and slow down. We have to remember that we are not just sitting perfectly still on a big, solid rock. It is more like we are riding on a wobbly spinning top. And this spinning top changes how it moves every single time something really heavy happens on it. Because of all these heavy things moving around, most days actually end up being a few tiny milliseconds longer than 24 hours. A millisecond is incredibly short. We as humans cannot feel this change in our bodies. We do not notice it when we look at our normal clocks. But scientists have highly advanced tools called atomic clocks. These atomic clocks are so perfect and so exact that they can easily measure these tiny fractions of a second. Over very long periods of time, those tiny little milliseconds start to add up. They join together piece by piece. And as they do that, the total length of a day slowly, surely increases. That is exactly how our normal 24-hour day is starting to drift toward becoming a 25-hour day. To verify this phenomenon and prove that the Earth is indeed hitting the brakes, modern scientists had to turn to ancient history. They gathered and meticulously analyzed nearly 3,000 years of astronomical records kept by our ancestors. Thousands of years ago, ancient peoples across various civilizations paid incredibly close attention to the sky. To them, a total solar eclipse was not just a cool astronomical event to watch through safety glasses, it was a terrifying, world-altering omen. Kings, high priests, and the earliest astronomers painstakingly carved the exact times, dates, and geographic locations of these disappearing suns into clay tablets, ancient scrolls, and delicate manuscripts. For the sky to go completely dark during a total solar eclipse, the celestial choreography must be flawless. The sun, the earth, and the moon have to align with absolute mathematical perfection. The moon's shadow on the earth is relatively small, meaning that if the cosmic timing is off by even a single second, that shadow will race across a completely different part of the world. Today, astrophysicists can track the moon's orbital movements with unbelievable precision. During the Apollo missions, astronauts left specialized retroreflective mirrors sitting in the dust on the lunar surface. Today, scientists at observatories on Earth routinely fire high-powered lasers at the moon, wait for the photons to bounce off those exact mirrors, and time how long it takes the light to return. This allows us to measure the distance to the moon down to the millimeter. Because we have such incredibly precise data regarding the moon's current orbit and speed, we should theoretically be able to use a computer model to rewind time, almost like scrubbing backward on a YouTube video, and watch every single ancient eclipse fall exactly over the ancient cities where history claimed they occurred. But when researchers actually ran those historical numbers through their supercomputers, a glaring problem emerged. The computer models showed the moon showing up either too early or too late. The path of totality simply wasn't falling where the ancient Babylonian or Chinese records dictated it should. The shadows were completely out of alignment with historical reality. This massive historical puzzle only resolves itself when you factor in one crucial, invisible detail. Earth's rotation used to be just a little bit faster. When scientists adjust their computer models to make the ancient Earth spin slightly quicker, altering the rate of rotation over the millennia, suddenly all the historical eclipse records snap perfectly into place. The ancient accounts weren't wrong. Our planet has simply slowed down since those scribes looked up at the darkened sky. On average, this historical deceleration means our day increases by about 1 to 2 milliseconds every single century. It is merely a thousandth of a second, an increment so vanishingly small you will never notice it in your lifetime. But over the relentless march of deep time, it compounds. It adds up to about 1 full second every 10,000 years. When you do the final math on those numbers, it reveals that humanity is roughly 200 million years away from finally experiencing a natural 25-hour day. So, while the prospect of an extra hour of sleep is technically real, it is only a meaningful reality for whatever distant descendants of humanity might be inhabiting the Earth 200 million years from now. But what is the ultimate culprit behind this relentless planetary deceleration? What invisible hand is slowly bringing our spinning world to a halt? The answer is staring down at us every single night: the moon. Our lunar companion is not just a beautiful nightlight, it exerts a massive gravitational pull that actively shapes our world. The moon's gravity reaches out across the vacuum of space and physically grabs onto Earth's oceans, stretching them outward into two massive, bulging mounds of water known as tidal bulges. However, the dynamics of this relationship are complicated by speed. The Earth rotates on its axis much faster than the moon orbits around us. Because of this speed difference, those massive watery bulges do not just sit perfectly underneath the moon. Instead, they are constantly dragged slightly ahead of the moon's position by the aggressive rotation of the Earth. This creates a spectacular planetary-scale friction. The world's oceans are effectively being dragged across the surface of the planet, violently rubbing against the rocky seafloor, grinding over continental shelves, and crashing against coastlines. This endless, unimaginable rubbing generates massive amounts of friction, and in the realm of physics, friction acts as a cosmic thief. Where there is friction, there is heat. The gravitational tug-of-war with the moon is slowly taking Earth's kinetic rotational spin, converting it into heat energy through the churning of the oceans, and radiating that energy out into the cold void of space. Once that rotational energy is spent, it is gone permanently. Without some giant cosmic hand to spin our planet back up to speed, the moon serves as a slow, relentless, billions of years long brake pedal. Day after day, year after year, It stretches out our days little by little. And because of the universal law of conservation of angular momentum, the energy Earth loses in its spin is transferred directly into the Moon's orbit. This transfer of energy acts as a slingshot, slowly pushing our satellite further away from us. As much as early science fiction feared the Moon crashing into the Earth, the exact opposite is happening. The Moon is slowly abandoning us, drifting further out into the solar system by about 1.5 inches every single year. Eventually, if given enough time, this immense braking force could push the Earth into a permanent, terrifying state known as tidal locking. Interestingly enough, this is a process that the Earth has already inflicted upon the Moon. Millions of years ago, the Earth's superior gravitational pull grabbed onto the Moon, slowed its own rotation down, and eventually locked it into place. This is precisely why humanity never sees the far side of the Moon from the surface of the Earth. Its rotation perfectly matches its orbit around us, keeping one face permanently pointed in our direction. If the universe returns the favor, and Earth slows down enough to perfectly match its own orbit around the Sun, our cycle of day and night will be completely obliterated. Our beautiful blue marble would transform into what astronomers chillingly call an eyeball planet. Because the Earth would no longer rotate relative to the Sun. The star would just hang motionless in the sky, completely fixed in place. The side of the Earth permanently facing the Sun would become a blistering, scorched, apocalyptic desert. This would be the pupil of the eyeball, baked by endless, unyielding solar radiation until all moisture evaporated into the sky. On the exact opposite side of the globe, plunged into eternal, unbroken darkness, the temperatures would plummet to absolute extremes. The dark side would freeze into a colossal, lifeless, mile-thick shell of ice, representing the white of the eyeball. The only potentially habitable zone on this transformed world would be a region known as the iris, or the Terminator line, a thin, twilight ring caught directly between the boiling, eternal day and the frozen, eternal night. But even this narrow strip of land would hardly be a paradise. The atmospheric dynamics of such a world would be violently chaotic. You would have superheated, expanding air from the day side violently rushing to smash into the dense, freezing air of the night side. This intense temperature gradient would guarantee that this twilight zone would be subjected to insane, relentless, hurricane-force winds whipping across the surface without end. Furthermore, without the centrifugal force of Earth's spin to help shape the location of the oceans, water would slowly boil away from the hot regions, migrate through the atmosphere, and precipitate as ice in the colder zones. Coastlines, continents, and the very map of the world would be entirely reshaped into an alien, hostile landscape. The planet would not just have longer days, it would become entirely unrecognizable as the Earth we know and love today. However, there is a strangely comforting bright side to this terrifying apocalyptic scenario. We will absolutely never have to witness it happen, and neither will our descendants, at least not while watching from any nearby vantage point. When astrophysicists run the mathematical models to completion, the math indicates it would take roughly 50 billion years for the Earth's rotation to completely stop and for the planet to fully transform into a frozen eyeball. Our solar system simply does not have that kind of time left on the clock. Our Sun, a relatively average yellow dwarf star, is currently middle-aged. In about 5 billion years, long before the Earth's spin ever grinds to a halt, the Sun will exhaust the hydrogen fuel in its core. When that happens, the delicate balance between gravity pulling inward and nuclear fusion pushing outward will collapse. The Sun's core will contract and heat up, causing its outer layers to violently expand outward. Our Sun will transform into a massive red giant star. As it swells to hundreds of times its current size, it will mercilessly swallow Mercury, consume Venus, and eventually reach the orbit of Earth, likely engulfing and vaporizing our planet entirely. We won't end up as a frozen, motionless rock stuck in a perpetual twilight. We will end exactly how we started billions of years ago, as scattered, glowing cosmic dust drifting through the vacuum of space. By the time the Earth faces this fiery demise, humanity will undoubtedly look vastly different than it does today. Given 5 billion years of technological evolution, we certainly won't be sitting around on the surface of the Earth, waiting for the Sun to expand. We might be scattered across the galaxy, living in massive artificial orbital habitats or ring worlds built around younger, more stable stars. Some factions of humanity might engineer colossal Dyson spheres, megastructures designed to entirely encapsulate a star and harvest every single photon of its energy output. Others might venture to the galactic core, drifting near supermassive black holes and utilizing their immense gravity and rotational energy in technological ways that our modern minds can barely begin to comprehend. It is even highly possible that entire civilizations of our descendants won't require physical bodies at all. Trillions of sentient minds could exist as uploaded digital consciousnesses, living out millions of lifetimes inside utopian simulations connected through a galaxy-wide quantum network, entirely freed from the fragile constraints of biological life and physical planets. Whatever extraordinary fate our distant future holds, the Earth will simply be remembered as our cradle. It will be an ancient, long-gone planet that successfully concluded its story, having given us exactly the time we needed to grow, evolve, and ultimately take to the stars.